Simplifying principal nth roots. If I have the cube root of a, that this is my index, this is my radicand, and this is my radical symbol. If I have the square root of 4, I know that that's 2. I have an understood index here of 2. Now the definition of the principal nth root is the nth root of a is equal to b, which means that a is equal to b raised to the nth power. So I know that the square root of 16 is equal to 4, which means that 16 is equal to 4 squared. And I know that the cube root of 8 is equal to 2, which means that 2 to the third power is equal to 8. Let's simplify. We factor the radicand. If I have the square root of 32, then first I factor it out, and I know that it's going to be 16 times 2, which is 4 times 4 times 2. Since it's the square root, there's an understood index of 2 here. I know for every 2, they're going to come out as 1. I wind up with the 4 coming out, and the remainders stay in. Now let's look at the cube root of 8. Well, the cube root of 8, if I factor that out, I have 2 times 2 times 2. In this case, since it's a cube root, I have an index of 3. For every 3, they come out as 1. So I wind up with just 2. What if I have the cube root of a negative 64? Well, that is the cube root of a negative 4 times a negative 4 times a negative 4, which is going to wind up being negative 4. And I can do this because I have an odd root, whereas if it was a square root, I would not be able to do it. Let's look at number 4. If I have the fourth root of 1 over 16, then that's going to be equal to root 4, or the fourth root of 1/2 times 1/2 times 1/2 times 1/2. So there are 4 of them. So that's going to give me 1/2. For every 4, then, they come out as 1. Let's look at an example with variables. If I had the square root of 25 times x to the 4th y squared, then that would be 5 times 5 times x times x times x times x times y times y. So I'm going to have 5 x and y. So x squared y. Okay, now we're going to combine like radicals. And the way we do this is if we have 2 or more radicals, we can combine them if they have the same index and if they have the same radicand. The first example we have is 4 times the square root of 7 minus 2 times the square root of 7. Well, my roots are understood 2's, so they do have the same index and they do have the same radicand. So I can simply just take my coefficients and subtract. 4 minus 2 gives me 2 times the square root of 7. Let's try another example. Number 2. If I have a negative 8 times the square root of 12 plus the square root of 3. Well, I'm going to simplify that. I know that that would be 2 times 2 times 3. I would have a negative 8 times, and let me go ahead and just work all this out. I would have 2 times 2 times 3 plus the square root of 3. I know I'm going to have that 2 come out and multiply here, giving me a negative 16 times the square root of 3, plus I've understood 1 in front of that square root of 3. Now I'll just take my coefficients. Negative 16 plus 1 gives me a negative 15 times the square root of 3. Now let's look at a third example. The cube root of 3, 8 times x to the 4th power. I'm going to rewrite this as cubes. 8 is 2 cubed, x cubed, and then times another x. We're simplifying this a little bit easier way. I know I can take my cubes out, so I wind up taking a 2 out and an x out times the cube root of x.